Unlike tectonic plate boundaries like the San Andreas Fault or the Himalayan region, the New Madrid Zone is located in the middle of the North American plate. This intraplate setting makes it an anomaly in earthquake science. The forces acting on this region originate far away from the area itself, driven by the slow but persistent movement of tectonic plates. Stress from these distant movements travels through the plate, eventually concentrating in weakened zones like the Real-Foot Rift. Scientists believe this ancient rift's faults remain active because of stress redistribution in the crust. This stress accumulates over centuries, and when it surpasses the strength of the rock, it is released as an earthquake. However, the exact mechanisms that lead to such powerful earthquakes in this area remain a topic of ongoing research. If an earthquake similar in magnitude to the 1811 to 1812 events occurred today, the consequences would be catastrophic. Unlike the early 19th century, the region now has a dense population, major cities like Memphis and St. Louis, and critical infrastructure such as bridges, highways, and pipelines. The effects would ripple far beyond the immediate area. The seismic waves would likely damage or destroy buildings not designed to withstand such forces. Many structures in the region are not built to earthquake-resistant standards, making them vulnerable to collapse. Power lines, water supplies, and gas pipelines could be severely damaged. This would lead to prolonged outages, fires, and potential contamination of water sources. Bridges and highways across the Mississippi River could fail, isolating communities and halting commerce. River traffic, vital for trade, would be disrupted, impacting the national economy. As seen in 1811 to 1812, aftershocks would continue for weeks or months, compounding the damage and making recovery efforts even more challenging. The financial toll would be immense, potentially reaching hundreds of billions of dollars. Insurance claims, rebuilding costs, and lost productivity would strain local and national resources. The most profound effect would be on the people living in the region. Thousands could lose their homes, and the potential for casualties would be high, especially in densely populated urban areas. Emergency preparedness efforts in the region have increased in recent years, with agencies like the Federal Emergency Management Agency, FEMA, conducting drills and raising awareness about the risks. However, challenges remain. Many residents are unaware of the danger, and funding for retrofitting vulnerable infrastructure is limited. Geologists continue to monitor seismic activity in the New Madrid Zone, using advanced instruments to track even the smallest movements. While predicting the exact timing of an earthquake remains impossible, these efforts are crucial for understanding the region's seismic behavior and preparing for the worst. The New Madrid seismic zone serves as a stark reminder of Earth's unpredictable power. While centuries might pass between major earthquakes, the risks are ever present. The lessons of 1811 to 1812 highlight the importance of vigilance, scientific inquiry, and preparedness. As we advance in our understanding of the Earth's inner workings, we must also ensure that our communities are equipped to withstand the next major earthquake, whenever it may come. More on the 1811 to 1812 New Madrid earthquakes, societal responses, and folklore. Detailed explanations of intraplate earthquakes, the mechanics of the New Madrid seismic zone, and theories for stress accumulation. Insights into current seismic monitoring, emergency preparedness, and risk mitigation strategies. Engaging what-if situations, imagining a repeat of these earthquakes today. Exploration of how such an event could affect modern infrastructure, the environment, and the economy. Let's dive in. The thought of another major earthquake in the New Madrid seismic zone is unnerving. A region so quiet most of the time might seem unlikely to produce catastrophic seismic activity. Yet, beneath its calm exterior lies a complex and active fault system that geologists say is building up stress once more. To understand the New Madrid seismic zone, NMS said, we need to explore its unique geology. Unlike the well-known tectonic boundaries, such as the San Andreas Fault, where two massive plates grind against each other, the NMS said. Millions of years ago, this area was a failed rift, an attempt by the Earth's crust to split apart. Known as this geological scar remains a zone of weakness, where ancient faults occasionally reawaken due to stresses transmitted through the North American plate. But why does it still shake here? Scientists have theorized several reasons, the last ice age placed immense weight on North America. As the glaciers retreated, the Earth's crust began rebounding, redistributing stress across the continent. This process continues to affect the region. Beneath the crust, the mantle flows slowly but powerfully. Uneven flow patterns may exert stress on weak points like the Reelfoot Rift. Although far from active boundaries, forces from the Atlantic Ocean's spreading ridge or the Pacific Plate's movement might ripple through the lithosphere, affecting areas like New Madrid. The New Madrid earthquakes were as much a social phenomenon as they were a natural disaster. Accounts of the time reveal the profound impact on communities, many of whom interpreted the quakes as divine punishment. Churches overflowed with worshippers, seeking repentance for perceived sins. Native American tribes, meanwhile, incorporated the earthquakes into their oral traditions. Some tribes saw the events as warnings from the spirits, signaling a need to respect the earth. At the time, the scientific understanding of earthquakes was virtually non-existent. It wasn't until the mid-19th century that seismology emerged as a field of study. Today, we have a far better grasp of seismic events, but the New Madrid earthquakes remain mysterious. Since the late 20th century, scientists have installed a network of seismographs throughout the Mississippi Valley. These devices constantly record tremors, revealing a surprising fact: the ground is still moving. Even though the earthquakes are too small to be felt, they hint at ongoing activity deep underground. GPS data shows minute shifts in the Earth's crust, suggesting that stress is building once more. Modern technology has enabled the development of early warning systems. Though these systems can provide only seconds to minutes of warning, even that brief notice could save countless lives by allowing people to take cover or shut down critical infrastructure. Imagine this: it's an ordinary day in the Midwest. People go about their business, unaware of the ticking geological clock beneath them. Then, without warning, the ground begins to shake violently. Buildings not designed to withstand seismic forces collapse. Roads and bridges buckle. The Mississippi River temporarily reverses its flow, inundating low-lying areas. Cities like Memphis and St. Louis, with their dense populations and critical infrastructure, face chaos. The economic impact would be staggering. A major earthquake in this region could cost hundreds of billions of dollars in damage, disrupting industries, supply chains, and daily life for millions of people. The environmental consequences would also be severe. Liquefaction, where the ground temporarily behaves like a liquid, could swallow entire structures. Agricultural land could be rendered unusable, and the river system might face long-term disruptions. Governments, scientists, and engineers have spent decades preparing for the next big quake. New building codes in the region now require structures to be more earthquake-resistant. Retrofitting older buildings remains a priority, but the costs are high, and progress is slow. One of the biggest challenges is raising awareness. Unlike Californians, who live with the constant reminder of seismic activity, many Midwesterners are unaware of the risks. Public education campaigns aim to change this, teaching people how to prepare and respond. Even if you don't live near the Mississippi Valley, the ripple effects of a major earthquake could reach you. Disruptions to transportation, energy, and commerce would affect the entire nation. The Mississippi River is a critical artery for trade, carrying goods from the heartland to global markets. If the river were obstructed, the economic consequences would be felt worldwide. The New Madrid seismic zone remains a focus of intense research. Scientists hope that by studying this region, they can unlock the secrets of intraplate earthquakes and improve their ability to predict them. Some researchers are exploring whether climate change might play a role in seismic activity. As rising sea levels and changing weather patterns alter the distribution of weight on the Earth's surface, they could potentially influence stress levels in fault zones. The story of the New Madrid earthquakes is a reminder of the Earth's immense power and our vulnerability in the face of natural disasters. As we look to the future, the question is not whether another major quake will occur, but when, and whether we'll be ready. In this age of advanced technology and global connectivity, we have the tools to prepare. But it requires collective effort, from governments and scientists to individuals and communities. The Earth's secrets are buried deep, but one thing is clear: the ground beneath our feet is never as solid